Hi, welcome back to my channel. This video is part 2 of Prestressed Concrete. Are APS, BP, ROP, FC prime I, FPY, FPU, FPS, FSE, Omega, Omega prime, and Rho prime. So please find time reviewing and memorizing maybe or remembering what those values means and what are they representing. So the permissible stresses in concrete can be either strength of concrete immediately after pre-stress. Yun yung ginawa natin kanina, yung step 1. We use the following values. But there's no need for me to elaborate this one because for pre-stress, we're only after the concepts. So kunin na lang natin kung ano yung mga importante sa kanya. Number 2, stresses in concrete at service loads. Ito yung ginamit natin dun sa number 3 or 5.3 of our discussion. Yun yung due to your superimposed load or your service loads after allowable for all pre-stress losses. It can be categorized into certain limits. So yan siya, A, B, and C. Again, there's no need for me to elaborate these values because it will just be used on our sample problem and you could see how we can apply these limits. All right? Tanggapin na lang natin na kapag situation 1, there are 3 cases under that. Situation 2, there are 3 cases under that. Shall not exceed the following. For your permissible tensile stresses and pre-stressing tendons, according to the code, if you're designing already or you're applying it in the actual, due to jacking, it is 0.94 FY. Ano yung FPY? That's your yield strength, but not greater than 0.8 FPU. Expect the elaborated discussion for this in your review or correlation. For this course, it's just an introduction on what you expect would be the limits of your values. So medyo madami siya for pre-stressing. So I suggest that you use an index card to summarize the following. All right? For the factored pre-stressing force at the anchorage device, PPU shall not exceed at least A through C, where 1.2 is your load factor. Meaning, for this application, it will apply already on your ultimate stress design kasi meron na siyang factors, okay? So take note that there are times that it will be applied under factored loads or load factors. So the last one is your maximum jacking force designated by the supplier of anchorage devices multiplied by 1.2. But mostly, this will be applied on actual applications. No? For theoretical, later on, makikita natin kung ano yung working equation to use. So this is the one to remember. We will use this in this term, okay? Your FPS is equal to FPU multiplied by the quantity 1 minus gamma P over beta 1 multiplied by the quantity density P or rho P, FPU over FC prime plus V over DP multiplied by omega minus omega prime. All of the meaning of the quantities here are taken or can be seen from first slide under your pre-stress losses in NSCP 2015. So ang gagamitin lang natin for today and for this term, ang mabibigay ko lang is yung application of this equation. Okay ha, I repeat ha, yung ating mga kanina, supplemental lang yon. it will guide you to properly compute values for pre-stress in your pre-stress concrete or pre-stress losses. So again, FPS is equal to FPU multiplied by the quantity 1 minus gamma P over beta 1 multiplied by rho P FPU over FC prime plus D over DP multiplied by omega minus omega 1. So if we can absorb this equation, please write it first kasi mamaya gagamitin natin for the sample problem. I'll give you a minute to write this equation so at least you'll be guided when we are using while we are using it later. So marami siyang kailangan tandaan and provision. I'll give the floor for the correlation regarding this. Dito na lang ako magpo-focus sa equation na to. Kasi ito yung nakita kong binibigay sa board exam. Alright, next, other values for FPS could be when members with unbonded pre-stressing tendons and with a span depth ratio of 35 or less. Pagka naman for members with unbonded pre-stressing tendons with span to depth ratio greater than 35, you can yield your gamma P to be 0.55, 0.40, 0.28 if the ratio of FPY and FPU are as follows. This is also important. Please take note of this relationship. Your YP is 0.55, 0.4, 0.28, depending on the values of your FPY and FPU. Okay, so aside from the equation a while ago, please take note of this one. I will say when to take note of the equation. The 85, 48, 44. What's this, James? Okay, alright, walang problema. Kasi baka correction siya or what. So, error lang po yun, guys. So much for the commercial. Let's continue. Other than values for your FPS, there are also provisions on the NSCP that you can apply next time, not in this course anymore, or not at this time. I will not discuss it kasi medyo mas mahaba siya. Parang 3 linggo siya ata kung may explain ko. Hindi ko siya kayang i-explain ng isang term lang. So ibibigay ko na lang yung provision and then we'll just focus on the FPS and then on your YPs. Limit for reinforcement for flexural members are taken here. Okay? If I will not discuss, it will not be included on the exam. Pero I have to provide you at least reading materials para makita mo kasi baka pag nagbabasa ka, it will make sense. Pero for now, if that does not make sense, at least focus on the FPS and then on the YP I gave you a while ago. So meron tayo dito when a reinforcement ratio is 0.36 beta 1, the design moment strength shall not exceed the moment strength based on the compression portion of the couple. And your minimum steel ratio would be 0.004 ACT. ACT is the area of the part of the cross-section between the flexure tension phase and the centroid of the gross section. Dito, ang hindi lang natin masyadong familiar sa ating muka or sa ating understanding is your beta 1. Taken from the latest code of NSCP, which is the 7th edition, dated 2015, your beta 1 would yield to a value of 0.85 if the ratio or if the range of your FC prime is from 17 to 28. If it becomes greater than 28 but less than 55, you need to use this value, 0.85 or iteration, 0.85 minus 0.05 FC prime minus 28 over 7. And lastly, your beta 1 could have a value of 0.65 if we are using the strength of my concrete at the 28-day period greater than 55. This one, remember, Okay, this one, write on your equations. This will also be used on the first topic of course outcome 2, okay, which is ultimate stress or ultimate strength design. All right. Pre-stress losses. The flexure stresses calculated for beams, which was 18% on our previous discussion, was based on initial stresses and pre-stress tendons. These stresses, however, become smaller with time over a period of roughly 5 years. Due to several factors, these factors include elastic shortening of concrete, shrinkage of concrete, creep of concrete, frictional loss, relaxation of steel or tendons, anchorage take up. This is how we can summarize your losses. If we have denoted that there are two categories or methods for construction of pre-stress, we have the pre-tensioning and we have the post-tensioning. Under pre-tensioning, losses will occur categorized into six. There are times that it will happen, there are times na hindi. Like this one. For pre-tensioning, your losses does not occur due to frictional loss and due to anchorage take-up. So kung masyadong maraming friction or meron kayong anchorage na gagawin doon sa mga material mo, pwede mong gamitin yung yung aking pre-tensioning kasi hindi siya masyadong naaapektuhan. Pero aside from that, other than that, here, kung gusto mo naman na hindi masyadong magkaroon ng losses, pero yung type ng construction mo is about elastic shortening or concrete, meaning siguro masyadong malamig doon or masyadong mababa yung temperature, mag-post tensioning ka para there will be no losses for your concrete. Ibig sabihin ng no losses, wala nung 18% from our previous problem. This is how you can use this table. All right. So I hope that in the future, on your future careers or endeavors, you will be able to apply this information. Knowing this information, we will now solve the last problem for course outcome 1 that covers quiz 1. From a board exam question, a pre-stress bonded rectangular beam has a width of 300 millimeters and an overall depth of 600 millimeters. Then, effective depth of tendon is given to be 538 millimeters. The pre-stressing tendons has an area of 900 square meters with a specified tensile strength of 1.9 gigapascal. As we remember, your tendons should have a good or a very large strength. No, ito, 1.9 gigapascal. Contrary to your tensile strength, specified tensile strength, your specified yield strength has given to be equal to 1.65. The specified compressive strength of concrete is equal to 35.5. According to the board problem, you are to compute three values. Number one, calculate the ratio of the pre-stress reinforced in percent. Number two, calculate factor for type of pre-stressing tendon equal to YP. Calculate the stresses in pre-stressing steel at nominal flexural stress, strength FPS in megapascal. So if you are correct from the previous three examples, meron ka ng 3/75, you will be correct here. You already have 6/75 on your board. So that would serve as your inspiration, no? For you to see what is the essence of what we're doing right now. On what we are doing right now, we can summarize the formula or the problem in this way. Let's solve for number one, calculating for the steel ratio. What's our steel ratio? That's our raw P. Raw P would be equal to APS over BD. This is formula-based. So kung makakapag-summarize ka ng formula, mailalagay mo siya, and then magkakaroon ka ng easy access, you can easily answer the question for this type, or for the you can easily answer this type of questions. What would be my APS? From the problem, APS is given to be 900 square millimeter. What is my B and D? My base is 300 and my overall depth is 600. Can you please give me the value of rho P? Your rho P would be equal to 900 over 300 over 538. Anyone from the class? It is 5 times 10 to the minus 3 according to Mark. So Mark, I think, has no plus 10 yet. So I'll give him plus because it's the first one. All right. So what we could do, what we could have is, let's use 5 decimal places, but please store the value on your calculator, 0.00558. You already have an answer to the board exam, 0.0058558, if you will remember the formula. So it matters for you to have easy access on the formula. Any questions so far? All right. Okay. I'm sorry ha. I have to make it fast already kasi kailangan lang naman natin ng mga equation and really I'm not feeling well. So for the sake of the discussion, let's continue. Okay? So solving for factor of pre-stressing tendon. Okay? How do we solve for the factor of your pre-stressing tendon? Your factor for pre-stressing tendon is your YP. In our solution, we can solve for YP when we know the ratio of FPY over FPU. From the problem, nakita natin na specified tensile strength is 1.9. That's my FPU. My specified yield strength is 1.65. That's my FPY. Sometimes medyo malilito ka kung ano yung ultimate, ay kung ano yung U or ano yung Y. Ang tandaan mo na lang yung specified yield strength. Yun yung may Y. Tapos kung ano yung matitirang value, yun yung PU mo. Kasi ito, kung gagamitin ko ng 1.65 for my FPY, automatically I will use 1.9 for my FPU. The ratio would be equal to 0.868. This is not equal to the whole number. It should only be equal to 0.868. Just correct that and try if it would result to 0.868. 1.65 over 1.9. Will it be the same for you? 0.868? Typo lang po yan ha, hindi yan whole number. Alright. Since we have the ratio for your FPY and for your FPU, which is your yield strength and your tensile strength, we can now use these values. Sabi ko, tandaan nyo ito. I-save natin. Sabi niya, kapag ka daw yung FPY over FPU ko is greater than 0.8, automatic YP is 0.55. Kapag greater than 0.85, 0.40. Kapag greater than 0.9, 0.28. 0.868 will be automatically greater than 0.85. Dapat yung nearest ha, nearest nung value. Dito nakuha natin that my FPY over FPU is greater than and nearest to 0.85. Therefore, I will use YP equal to 0.04. So it's a matter of memorization. It's a matter of familiarity on where you get your values. Sir, paano po pag 0.835? It is always the lower value. Okay? Nearest whole number or nearest whole decimal. Okay? Pag ganun po, according to Rosemary, paano pag 0.835? Because it's between 0.8 to 0.55, mas malapit siya sa 0.8. Kaya dapat siya ay doon lumaglag. 0.55 will be your YP. Did I answer your question, Marie? Yes. If it's 0.84, it's still 0.55. If it's 0.84, it is still 0.55. If it is 0.88, it is zero point 0.4 na. Kailangan hindi siya sumobra. Basta less than siya, dun ka pupunta sa one step lower to that. Okay? Nearest number to that. You're welcome. So any other questions? Papaano kung ang value ko ng aking ratio is 0.820? Okay, 0.820. What will I use? Kunyari, 0.820. Yes, it would be 0.55. Thank you. Thank you for understanding that right away. Okay. So since we have your YP already, we will continue to solve our values. If you have your YP, you already have 2 points on the board exam, but because tama tayo kanina sa tatlo, 5/75. Let's make it 6 points. Okay, let's make it 6 points. I have a question pala. Sir, paano naman po if exactong 0.85? Pagka exactong 0.85, if you can see, there is no sign here. Ibig sabihin, papatak pa rin siya dun sa 0.8, which is 0.55. Kasi wala naman tayong equal sign. Ibig sabihin, yung 0.85, hindi siya greater than 0.85. It would still fall for greater than 0.8. Did I answer your question, James? Okay, according to Maria, sir, kapag 0.89, bali 0.4 pa rin gagamitin. No na. If my ratio, yung aking FPY and yung aking FPU, the ratio of that, sabi na Maria, is 0.89. Ano to? Di ba yung 0.89 is larger than 0.85, but it's less than 0.9. We are always a step lower. We will use 0.4. Okay? Did I answer that question, Maria? All right. Any other clarifications that you think matters? Okay? That's very good type of, magaganda yung mga tanong natin. Do not hesitate to ask, okay? Do not hesitate to ask. So what we have is no more questions, all right? So meron na tayong ratio, ROP, meron na din tayong YP, which is 0.4, okay? So now we will solve problem 3 for section 3 of problem number 6. Solving for stress in the pre-stressing steel, we will use this equation. FPS minus FPU multiplied by the quantity 1 minus YP, which we computed, beta 1, multiplied by ρP, which we computed, stored on our calculators, multiplied by FPU, that's given, equal to 1.9, FC prime given, equal to 34.5, plus D over dP multiplied by omega minus omega prime. If we will remember, our omega is the ratio of your pre-stress reinforcement intention. And number 2, yung omega prime ko is my steel, my ratio of my compression steel due to pre-stressing. So yun yung aking ginagamit. Kaya naging rho and rho prime. In here, your rho is to be remembered as your pre-stress tension reinforcement and a non-pre-stress ratio, non-pre-stressed compression reinforcement. Okay? Bakit ko sinabi yon? Kasi gusto kong malaman nyo or ma-explain natin kung bakit nagiging 0 or bakit nagkakaroon ng value yung omega at ng omega prime. Let's continue if you have no questions with this. Ito yung equation, tapos unahin natin yung tanong natin kanina. Sabi natin, this is our first time to see your beta prime. But my beta prime is taken from NSCP, section 424, if I can remember correctly. This is ranging to from 28 to 55. Kasi 34.5 yung ating FC prime. From our table, we would use the middle row. Kasi nandun siya nagfo-fall. Greater than 28 but less than 55. Using this value or iteration, can you please compute for beta prime in 5 decimal places? 0.85 minus 0.05 multiplied by FC prime minus 28 over 7. So according to Luis, this is, I think, the first time he's answering. So let's give him plus 10 if this is correct. Okay. How about the others? Can I get, all right, Aniza, sorry. All right, okay. Thank you. So, wag muna tayong matulog. Konti na lang, guys. Konting-konti na lang. We are almost done. Okay, let's check. If this is correct, Luis gets plus 10 on the quiz 1. So, ito yung ginamit natin. Beta 1 is 0.80357. Let's store that in the calculator because it is critical value. Because we're playing with gigapascals. Yung gigapascal times 10 to the 6 for it to become Pascal. Ay, times 10 to the 9. So, medyo malalaki yung values. Paki-store po yung aking beta 1. Next thing is to realize the values of your omega and omega prime. Sa problem natin, wala tayong nakitang reinforcement for tension and reinforcement for compression. Ang nakuha lang nating reinforcement ay nung aking tendons. Establishing that statement, we can relate that since there are no reinforcements in tension and compression, your omega and omega prime is equal to 0. It will change po kapag ka naglagay na siya ng reinforcement for steel, for tension and for compression. How would you know? You would either get a figure or the problem would tell you. Pero sa problem, wala naman tayong nabasa na meron tayong reinforcement for tension at meron tayong reinforcement for compression. So how would it look like? If we could have this as your pre-stressed steel or concrete, this is my pre-tendons. Ito yung aking reinforcement for tension. Ito yung reinforcement ko for steel. But for the problem, wala siyang nilagay. So wala akong ratio of my reinforcement for tension and for compression. Okay? Sana po malinaw yon kung bakit naging 0. If hindi po malinaw, there's a recording. You can go back to that, or you can just simply absorb this statement that since there are no reinforcement for tension and for compression, according to the code, omega and omega prime is taken as 0. So using this equation, can someone solve the value of FPS in terms of gigapascal? So according to someone here, 1.61. According to Limwell, how about the others? I think I made a mistake. Please give me the value for the Okay, how about the others? I'm computing also ha. Just give me time. So sagot lang kayo. Bigay nyo lang yung answer niya. Okay, according to you, the answer would be, I am correct pala. Kala ko mali ako. So meron tayong 1.61 gigapascal, 1.899, 1.899 for Trevor. I think the correct is from Erico. Okay, Erico Miquel. Is he the first one to give me the answer? Limuel. Limuel was the first one. Edilior. Okay, let's check the values. Kung makikita natin, this is the working equation. So, i-explain ko na lang para mag-arrive doon sa final answer. If you could see, this is gigapascal over megapascal. So, i-multiply mo muna ng 1,000. And then you start from the inside of the bracket. Itong aking expression na to, it's equal to 0 guys ha. Kasi wala nga tayong omega and omega prime. Anything multiplied to 0 is 0. So eto, nag-start na tayo dito. So 1.9 times 1,000 over 34.5 multiplied by the stored value of your rho p multiplied by 0.4 over the stored value of your beta 1 quantity 1 minus that answer and then multiplied by 1.9 gigapascal. Your answer would be 1.61 or 1,609.56 megapascal. So Limuel, Adelior, do you have a plus points already or wala pa? I'll give you one. So tama din si Erico. Okay, I'll also give him one. So Ceciliano. Erico, do you have the plus na a while ago? Okay, so any questions, guys? It's just a matter of memorizing the formula po. Kaya please familiarize yourself. If you cannot remember, write it on an index card kasi you can use that during the exam and for correlation and as well for the boards. Sir, ano po yung correction factor? The correction factor, which is, are you pertaining Maria for beta 1 or for raw? Ang final answer mo for FPS is 1,000, 1.89. Okay. Can you try, everyone, can you solve it with me? Ganitong gawin natin ha. 1.9 times 1,000. Sabay-sabay tayo. So 1.9 times 1,000, tapos equal, divided by 34.5. You multiply it with the stored value of your raw P, which is 0.00558, pero dapat exact value. Okay? And then you multiply it by 0.4, you divide it by beta 1, exact value also, and then you subtract the answer from 1, and then you multiply it by 1.9. You multiply the final answer by 1,000, it would result to this value. I don't know if you can see it. It's 1,609.56. Sir, hindi po ba yung 35 point yung gagawing MPA to GPA? Ah, it could be okay. Pwede naman yon. Ang akin lang is that it doesn't matter if you will convert MPA to GPA or GPA to MPA. Why? Because it would still yield to the similar ratio. Okay? Iko-convert ko yung aking MPA into GPA tapos i-divide ko sa 1.9, pareho pa rin yung ratio na lalabas. Yes, unitless kasi siya. For Maria, 1.6093, because maybe, are you using 0.0058 instead of this long value? Ito po yung naka-store ha, naka-raw P. Hindi ko ginagamit to. Ang ginagamit natin ay naka-stored value. Because dapat naka-stored kasi we are playing with gigapascals. So the correction is 1 million. It would matter. The answer is 1609. Ano ba yung sagot ko kanina? My answer is 1609.56. Ayun, kay Limuel lumabas siya. So, ayun, thank you. At least you already know, Maria. Kailangan laging exact ha. Gamitin natin yung exact. For this, will it now be 0.56? Pag ginawa mo, hindi mo ginagamit yung ano ha. Ay, okay po. Yung hindi po pala exact gamit ko. Okay, alright. Again, guys, when you see my equation to be like this, always remember our golden rule, no? The golden rule is only round off or round down at the final answer. Kung nakikita mo na iba yung font, either nagkaroon ako ng note sa kanya na nakastore yon, and then we use that exact values. Okay? So I hope that you will remember that, and wag pong magagalit kapag nagsosolve ka, ayaw lumabas ng final answer sa akin. First is ask yourself kung gumagamit ka ng stored value or not. Okay? Any other question or clarification? So pag tumama ka dun sa FPS, 1609.56, meron na tayong 6/75 sa boards. Yun lang yung kailangan mong tandaan ha. Itong long equation na to, itong long equation na po ito, tapos yung kanina, ito, yung relationship na to, and then yung last one is yung beta 1. Okay? Usually ginagawang 0 na lang tong omega for this lower level applications. Any clarification, class, or questions? All right, none. So kung nalunod tayo sa equation, okay lang po yon, normal yon, kasi mahaba talaga yung equation. So what you could do is help yourself in writing in your notebook, tapos trying to memorize. Kung hindi kayang i-memorize, index card will suffice your concern or your issue. I'll accept that there are no questions anymore, all right? I will end that with no questions. This is for quiz number 1. Okay, for quiz number 1, it shall cover outcomes 2, 3, and 4.